In this question, you have to find the equation of the line that passes through the point 5, 2 and is parallel to the line with this equation. And you also have to find the equation of the line that passes through that same point and is perpendicular to that same line. So two separate things to figure out. So first of all, a brief sketch or a simple sketch of this so you can see what is actually happening in this question. So y equals 2x plus 1. This is the gradient. Remember mx plus c. So the gradient of 2 and y-intercept of 1. So passing through somewhere up here. And y equals 2x plus 1. And the point 5, 2. Let's say that's over here somewhere. So what you've got is a line that's parallel to this line and going through that point. So it goes over here somewhere like that. And there's the line that is roughly parallel to this one and passing through that point 5, 2 right there. So the key thing in this question is the wording parallel to the line. So when two lines are parallel, they have the same gradient, and I'm going to call this line y1 is equal to something, and I'm going to call the gradient of that one actually m2, and I'm going to make that a 2, so that's y2. So m2 is equal to m1, and that's m1 in this equation here, the gradient in the first equation. So therefore m2, because they are parallel, the gradient's equal to 2, the same as this one. And all you need to find the equation of a line is a point that belongs to it and the gradient, and we've got both now. This point belongs to the line and that's the gradient. So all you have to do from here is to go y minus y1 equals m bracket x minus x1, and x1 and y1 are the point, and I'll put that point here, 5, 2. So this is always the x1 and the y1. And so y minus 2 is equal to the gradient, which is 2 bracket x minus 5. And all you have to do is expand that out. And so you get 2x minus 10, and then add 2 to both sides, and you get y equals 2x minus 10 plus 2, and then y equals 2x minus 8. Now, if you drew that down until it intersected with the y-axis, it's definitely got a negative y-intercept, which could be minus 8, and because I've done the steps correctly, it is minus 8. So that's the answer to part A. And going on to part B, the line is perpendicular. The other line is perpendicular to this line and going through that same point. So the line's going to be doing something like that. So it's going to have a negative gradient and it's going to have a different y-intercept again. So the key thing about perpendicular lines or lines that are at right angles to each other is that the gradient of this third one, it's going to be minus 1 over the gradient of the first one. And it doesn't matter which gradient I use here, but I'm going to put the first one in. So that's minus 1 on 2. And then that same point, 5, 2, belongs to this line as well. So you can use that equation again. Y minus y1 equals m bracket x minus x1. And then sub in the point 5, 2 and this gradient here. So y minus, and again it's going to be 2 equals minus 1 on 2 bracket x minus 5 this time. So minus 2 and multiplying out the bracket. So minus 1/2 times x is minus x on 2. Minus times the minus is a plus. 5 on 2. That becomes, and then getting rid of this 2, adding 2 to both sides, you get y equals minus x on 2 plus 5 on 2 plus 2. So y equals minus x on 2 plus 5 on 2, and 2 is 4 on 2. So y equals minus x on 2, and this equals 9 on 2 plus 9 on 2, which is 4.5. So that's the equation of the line that's perpendicular to this line, and I'm going to draw it in for you. Alright, so there's the line. It's not quite straight, but it's about the best that I'm going to get, and it's perpendicular, and you can show it with the right angle symbol there, and it's definitely got a negative gradient, and it's passing through somewhere above 1 on the y-axis, so the y-intercept of 9 on 2 or 4.5 over here looks good. So that's how you do this question, and I'll see you in the next one.